In section 11.9, we're going to talk about something called the normal distribution. And it's something you might have seen before. Sometimes they call it a bell curve. Let's start with some definitions. A discrete probability distribution has a finite number of possible events or values. Something called the continuous probability distribution can be any value in an interval of real numbers. If a data set is large and the distribution of its discrete values approximates a continuous distribution. Well, let's talk about what a normal distribution is going to look like. A normal distribution has data that vary randomly from the mean. So this is our normal distribution curve. Again, we call it a bell curve. It's very symmetric. And what I want you to notice is these percentages, because this is what's going to help us out in this section. In a normal distribution, 68% of the data fall within one standard deviation of the mean. So you'll notice this is the mean here in the middle. If I go one standard deviation this way and one standard deviation this way, 34 plus 34 is 68. 95% of the data will fall within two standard deviations of the mean. That means if I extend this out to two standard deviations this way, and I add those percentages, I'll get 95%. And then 99.7, almost all, of the data is going to be within three standard deviations of the mean. So if I, again, add all these percentages. Now, this really does make up 100%, even though at this point in time I've only added up to 99.7%. So where's the other 0.3%? Well, over here is going to be 0.15%, and over here is going to be 0.15%. Because 0.15 plus 0.15 is 0.3, and that was all I was missing from my 100%. So it's kind of out in that fourth standard deviation away from the mean. Sometimes there is an extraordinary factor that will affect the data, and that would otherwise be normally distributed. For example, let's say you toss a coin, but the coin you have is somehow weighted unevenly, so that every time you flip it, heads comes up. Well, in this case, the data could have a distribution that's something called skewed. That's an asymmetric curve where one end stretches out further than the other. So if you have no skew, you get this thing called the normal distribution curve. However, if it's weighted to the right, we have positive skew, and if it's weighted to the left, we call it negative skew. And I want you to note where the mode is. Remember, mode is the most frequently occurring number. So notice that the line for mode goes through the highest point on the curve. So let's look at problem number 1 and analyze a normally distributed curve. The bar graph gives the weights of a population of female brown bears. The red curve shows how the weights are normally distributed about the mean, which happens to be 115 kilograms. Approximately what percent of female brown bears weigh between 100 and 129 kilograms? Well, I want you to notice that the bottom of our graph is the weight in kilograms, and the left-hand side is the percent of bears that fall into that category. So if we want to find out the percent of bears that fall between 100 and 129 kilograms, we're going to look at from here, which is where 100 starts, to 129. And we're going to add the percents of those three bars. The problem is we kind of have to do some guesstimating about where those bars are at. And clearly the book does their guesstimating. So the first bar here is less than 25, so maybe it's like 23 or 24, and they used 23. When I guesstimate the percentage here, in the center bar, let's see, it looks like it's 42. I'll go with them on that. And then when I look at the percentage over here, that also looks like it's 23 because it looks like it's the same height as the bar over on the left. I add those three together and we find out that it's 88% of the bears. What if I said, what do you expect the weights of the female brown bear, or why do you expect the weights of the female brown bear to be normally distributed? Well, remember that bears can probably come in different sizes. However, most bears should be about similar in size. So the weights of most of the bears should be close to the average weight of the female bears, which is why we get a normal distribution. About what percent of the female bears weigh less than 100 kilograms or more than 129 kilograms? Well, if I look at the ones that are less than 100 but more than 129, I'd want to add up those percentages. So these two little bars here and here look like they're both at about 5 approximately. So I have 2 5s. And what about over here? I don't really see a bar, but the red line still looks like it's above the bottom. So maybe we'll call that 1 and 1, which is about 12% of the bears being less than 100 but greater than 129. Well, I want you to notice something. What happens when you add 88 plus 12? You get 100%. And you know you can't go over 100%. What percent of the female brown bear should weigh less than 115 kilograms? Well, I want you to notice that 115 was not one of the numbers at the bottom of the bar graph. But isn't it kind of between 110 and 119? Well, that kind of puts the line halfway down the graph. So if I said, what percent of the female brown bear should weigh less than 115 kilograms, it's probably going to be about 50%. In problem 2, it says, for a population of male European eels, the mean body length and one positive and negative standard deviation is shown below. Sketch a normal curve showing the eel lengths at 1, 2, and 3 standard deviations from the mean. So in these eels, the mean body length is going to be 15.7. One standard deviation away, one way is going to be 18.5, and one standard deviation the other way is going to be 12.1. So the first thing that I want to figure out is how far to the left and to the right of the mean is my standard deviation. Well, if you subtract these numbers, you subtract these numbers. So if you subtract the mean from one standard deviation, the mean from the other standard deviation, you're going to find out that it's 2.8 inches in either direction. So if I go and draw myself a normal curve here, we're going to call the mean at 15.7. Let me make that look nicer. So one standard deviation this way and this way is going to be 2.8 inches in either direction. So now I'm going to draw myself a little line down here. Use a different color. Okay, so this is 15.7. That's the mean. So when we went one direction, 2.8 plus 15.7 is going to be 18.5. And 15.7 minus 2.8 is 12.9. So those were the 3 numbers I already had. Well, let's go another standard deviation away. So let's see, I'll call that plus 1 minus 1. So now let's go to 2 standard deviations away in each direction. I'm sorry, my picture is not very symmetric. That means I'm going to add another 2.8. And I'm going to get 21.3. I'm going to subtract another 2.8, and I'm going to get 10.1. They want us to go to 3 standard deviations away, so let's go 1 more standard deviation, both directions. So 21.3 plus 2.8 is going to be 24.1, and 10.1 minus 2.8 is going to be 7.3. Down here should be the length in inches, and we always say that this way is the frequency of the measure. Now let's go back and see if we did this correctly. And here's the picture of what it should look like, and that is exactly what we got. So when we draw these normal distribution curves, I want you to start by drawing the normal bell curve. Then I want you to go and put where the mean is. Remember, the mean should be at the highest point. And then work on your standard deviations. If I were to go put the percentages in here, the 34% go on either side of the mean, or they're 1 standard deviation away from the mean. And then after your 34% are your 13.5%. And then after your 13.5% are your 2.35%. And then if you want to finish off the 100%, the 4th standard deviation is going to be 0.15% on either side. So if we wanted to find the probability of being between 2 different lengths, we could use these percentages to help us out. That's what we're going to come back to in problem 3.